Okay, so we're going to start this lesson on 14C, ordered selection and grouping. Now, this lesson is very similar to the previous one where we're talking about restrictions, and sometimes the question, there's some condition of the questions where three particular person want to stay together. So this type of question is about the grouping questions here. And then I'm also going to talk about the questions where there's some complementary events, and we can use the complementary method to work out the answers there. All right, so in general, like when we're dealing with the grouping questions, we usually first order the groups and then they order the individuals within each group. Okay, so if we have the grouping questions like, two particular person want to stay together, so what we need to do usually is we first order the groups. Once we finish ordering the groups, then we'll order the individuals inside the groups, okay? So this is very similar to the one we did last lesson, where I actually, combine two individuals or three individuals as one single group, and we talk about a permutation if we treat those a single group, and then once we finish that, we organize, we order the individuals within each group, okay? So that's the idea. Okay, so we're just going to start with something that's very similar to the previous, exercise, and I'll give you a few questions, and then we're going to talk about some special ways of dealing with, with the questions there. So let's just look at the question from the exercise. I'm looking at question 9. Okay, from this exercise. So the question 9 says, we've got a word behaving. And then the first part of the question is how many different arrangements or how many arrangement of letters of the word behaving, that the first one is end in ng. Okay, so that's the first question. End in ng. Right, so how do we do this question here? Now, think about the grouping methods here, right? So what we are going to do is we're going to group with ng together. So it's n in ng in this order. So I guess it has to be in this order here, n to be the first letter and g to be the second letter. And with remaining letters here, you can organize those in any, order you like. So therefore, so if you think about this now, you have, just give me 1 second. All right, so you've got 1, 2, 3, 4, 5, 6, and 7. 7 groups in total. So if we organize those 7 groups, that would be 7 factorials. Okay, so this is what happens when we first organize the group, right? We first order the groups, and then once we finish in the groups, then we start to order the individuals within the groups. But it looks like right now the ng, it says end in ng in that order here, so therefore we don't need to times by 2 factorial. So the final answer for this question here is just 7 factorial. Okay, that's actually pretty easy. All right, question B. The question says begin with 3 vowels. Okay, begin with 3 vowels, right? So the first thing we need to, identify the vowels first, right? So that's E, A, and I. Now, begin with 3 vowels, all right? So what does that mean is, in this case, as long as these 3 vowels is at the beginning, then it satisfies this requirement of the question. So therefore, firstly, we just group them first, right? So we've got B, H, V, N, and G left after we group E, A, I. So we just need to count how many groups we've got here. So we've got 1 group, 2, 3, 4, 5, 6. So in total, we have 6 groups, which is 6 factorials. All right, but this time, please also remember this time we need to organize what's inside of EAI in this group, because the question just says begin with the 3 vowels. So in this case here, we can have any order between EAI, can be IEA, so therefore we need to times by 3 factorials to finish this question. That's what we do. Okay, so that's question B. Now for question C, it says having 3 vowels occurring together. Oh, okay. That's interesting. I think I've made a mistake with the previous question. So the second, all right, I'll talk about it in a minute. Have 3 vowels occurring together. Okay, so I guess what I did previously is I did this question, with three vowels occurring together. So I guess like for the second question, part B, beginning with three vowels, which means I think the beginning letter has to be one of the three vowels there. So yeah, it's pretty difficult when we didn't, when I didn't read the question carefully. All right. So I guess this is what we need to do for the second part of for the third part of the question. All right. So in this case here, for the second questions here, for the second question, begin with three vowels. All right. So the beginning letter has to be three vowels. All right. So in this case here, I'm just going to use boxing methods here. All right. So we just need to count how many letters we have. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 letters. All right. Is that 8 letters? No. Okay. 8 letters. All right, so I've got 8 letters, all right, beginning with three vowels here, which means that beginning letter has to be either A or E or I. Okay, so it's 3 choices we have, right? So in this case here, the beginning letter, we've got 3 choices. All right, once we've done that, then we're taking away from, we're taking one vowels away from the actual remaining letters here. So therefore, we have 7 letters remaining. So therefore, the second box, we can have 7 different choices. It doesn't matter what letters anymore. It can be a vowel or it can be a consonant. All right, and then that'd be 6, 5, 4, 3, 2, and 1. All right, so therefore, the answer for this question will be 3 times by 7 factorial. Yeah, it's a bit tricky. Previously, I was thinking about beginning with 3 vowels. So is when you have all 3 vowels actually staying together, and that's what beginning with 3 vowels. Until I look at the question C, it says having 3 vowels occurring together. So in this case here, we need to have 3 vowels that join together as the beginning part. Then I'm now looking at this part of the question. Having 3 vowels occurring together, it doesn't matter whether these 3 vowels is actually at the beginning or in between. So therefore, this is still not correct as well. All right. So in order for us to actually do this question now, we just need to count. I think that's 1, 2, 3, 4, 5, 6. Yes, it is correct. Sorry. So that's 6 factorial, and then we times by 3 factorials. So that also means that previously I didn't even do the question correctly, because if we have 6 factorial, that just means this one can be placed within anywhere. Okay. So yes, I made a multiple mistake with this question. So you can see how easily you make mistakes, if you don't pay attention to the actual question. Okay. It's good. I make 3 mistakes, and I corrected myself. That's pretty good. All right. Now what I want to do is something that is in terms of a complementary event. So I'd like to show you our questions here. All right. So this one is not a question from the exercise. It's just a random question. All right, so for example 2, how many 7-letter words can be formed by using the letters A, B, C, D, E, F, G? Okay, so A, B, C, D, E, F, G. So you've got 7 letters, right? And then the question says, how many 7-letter words can be formed from these words here if vowels must be separated by at least 1 consonant? Okay, so this is the question. So vowels, must be separated by at least 1 consonant. All right, so this is a bit interesting. All right, if you look at identify the vowels here first, so that's E and A. So these 2 are the vowels. Now it says the vowels must be separated by at least 1 consonant. So by just looking at A, B, C, D, E, F, G, right now, yes, the 2 vowels is actually separated by this 3 consonant here. But it says it has to be at least separate by 1 consonant, which means that's a bit tricky, because you can have like only 1 consonant in between, or you can have 2, you can have 3, you can have 4, you can have more. So this is not easy, it's not that easy to deal with this question directly. So what we need to do is something using, the complementary situation methods here. So what we need to do is we basically find out what is the number of arrangements. Okay, so number of arrangements without any restriction. Okay, or the number of orderings without restrictions here. So let's just say if we don't care about any position of A and E, so in this case here, that is just equal to 7 factorial, all right? Because of, 7 factorial, you don't have any restrictions, so you can order those 7 letters anywhere you like, and then that's 7 factorials. All right, and then what we need to do is we need to find the complement of at least one, separated by at least one consonant. Okay, so the opposite to separate by at least one consonant is actually these two vowels stay together. Okay, that's the opposite. So what we need to do is now we find out the number of orderings or the number of arrangements with both A and E stay together. Okay, so if they are actually together, what is the chance? What is the, not the chance, but what is the arrangements there? So if we actually have A, E together, we'll have B, C, D, F, G. So in total, we have 1, 2, 3, 4, 5, 6. 6 groups, so it will be 6 factorials, and then we can change between A and E, so that times by 2 factorials. All right, once we've finished that, then here's the number of the orderings with A and E apart, or with at least one consonant that's in between of A and E. We'll be just using the total here, subtract the numbers there. All right, so therefore, all right, the number of arrangements all right, with A and E apart, all right, is equal to 7 factorial minus 6 factorial times by 2 factorial. Okay, so this is an example of the question where you are still using the grouping methods, but you're not really finding the number of arrangement directly, okay, because it's just too many cases. You can have 1 letters in between, you can have 2 letters in between. This is just using the method where we actually find the complement of that, and then we work out the answer that way. Okay. All right, so let's just move on to we'll try another question. So this lesson is not going to be a very long lesson, okay? It's very similar to the question we did last lesson there, okay? So just maybe find another question there. All right, okay, question 14. All right, so question 14 from the exercise. So we've got several parts of question 14, so let's do all of them. So question 14a, it says how many 7-letter words can be formed without repetition from the word include. Okay, so INCLUDE. All right, so how many arrangements? All right, there is no restriction, nothing. It just says how many 7-letter words. Okay, now remember, without any repetition, so you can't use the letter twice or 3 times. Can be formed. All right. Okay, so this is the question. So in this case here, we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 of them, and the question asks us to find how many possible arrangements there. All right, so it's just 7 factorial. So there's no restriction. So that question is pretty much that's it. All right, so pretty easy. Now the second question asks you about how many of these. So how many of these, does not begin with I? All right, so how many of it does not begin with I? Now, whenever I look at does not begin, I'm thinking about a complementary event, do not begin. So I'm thinking about a complementary event. So what about actually we find out how many of them actually begin with a letter I, okay? And then we use the total, which is equal to 7 factorial minus how many that's actually begin with letter I. All right, so if you think about it, all right, beginning with letter I means the letter I is never going to change. So you can rearrange the rest of the letters here in any order, but letter I has to be there. So in this case, we've got 1, 2, 3, 4, 5, 6. We've got 6 factorial possible arrangements there, with I to be the first letter. So therefore, we have 7 factorial minus 6 factorial to do this question here. All right. All right. Question C. How many end in L? All right, question C. How many end in L? All right, so you will have the last letter to be L, which means the rest of the other letters, it doesn't matter. So it's very similar to the previous case. We are going to have like I, N, C, U, D, E. With all of those, okay, now L has to be the last one. So that's going to be the last one. It doesn't really matter now. And then we just need to rearrange those, okay? So the L must be the last letter here, okay? Okay, so what we need to do is we can use the complementary way as well. How many end in L, we can actually find out in how many end not in L, and then we use the total to minus. Okay, so there's so many ways. That's that's what I want to say. There's so many ways you can do it. You can do this question by how many that's not ending with L, and then we use the total minus that, and then that's how many that's ending with L. So this is actually 6 factorials. Okay, next, question D. How many have the vowels and the consonant in alternating? Right, so we've done this before about alternating, right? So firstly, what we need to do is we actually identify the vowels and consonants from the word include, okay? So the vowels is I, U, and E, all right? And the consonant here is the rest of the other letters, so 1, 2, 3, 4. So basically, we've got 3 vowels and 4 consonants, okay? So 3 vowels and 4 consonants. Alright, so in this case here, if we're just looking the vowels to be like a circles and the consonant to be like in a triangles, the way to organize them is we can only have this way of arrangement, okay? That's the alternate places because we have one less vowels comparing to the consonant. So in this case here, the answer will be for the consonant, alright, it is equal to 4 factorial, and for the vowels, it's just equal to 3 factorials, and we multiply them together. And we can't times by 2 because you kind of have a vowel to be the beginning letter. Otherwise, it's not going to work this time. You're not going to have an alternating position if vowels to be the first one. Okay, so that's question D. All right. Okay, now question E. I'll probably just do up to question E. There's another 2 more questions at the end. You can actually try these 2 questions later on yourself. I want to save as many questions as possible for you to practice as many questions as possible. All right, so how many have the letter C immediately, okay, followed by letter D? All right, so what does that mean? You want to C immediately following the letter D, okay? In this case here, that just means the C and D must be staying together, right? Okay, so that's the idea. Immediately following, so there's nothing in between. Okay, so we're going to have a C and a D together. And in that case, we also need to make sure that D is before C. All right, C immediately following the D. So in this fashion here. So D and C as a group. All right, and then for the rest of the other letters, it doesn't matter now. We've got 7 letters, so we've got 5 remaining. So 1, 2, 3, 4, 5. All right, so what we need to do here with this, we can have 6 groups. So that's 6 factorials. And then you don't times, so please do not times by 2 factorial here. Just because that D and C must be in this fashion here. You can't have C that's before D, okay? Because of the question says C must be immediately following the D. Apart from that, that's all. You don't need to talk about whether D is here and C is there, because otherwise it's not really what the question is asking. All right, so that's all for this lesson. It's a short lesson because of the things you have learned in this lesson. It's very similar to the previous one, so that's pretty okay. Just let me know if you have any questions with the problems. I know I've got students already say I've got better way of doing the question. That's great. Okay, that's really, really good. There are many ways you can do questions in this topic. All right, thank you.